All right, so what they're asking us to do is to graph the exponential function. So there's a couple of key things that you need to make sure that you train your mind to see when dealing and specifically graphing and filling out a table of an exponential function. One of them is that if you ever were to plug the value of zero, it's actually quite easy to find the y because anything raised to zero is one. So you can see here we're going to have 2 raised to the x, which in this situation, at least when I'm plugging in my table, is 0. 2 raised to 0 is 1, so you'll notice you always end up with that number, that the multiplier out in front. So you can see here that already, I already found a point pretty easily, pretty quickly. You just got to make sure to train your mind to see these patterns. So that way you can get a little speedy with graphing these problems. So I can notice that my point is right about there. Let me go ahead and erase this one because that was an accident. Now, again, you could plug in values. I always suggest going up by 1, down by 1, because it's super easy. You can see here that your base, the number that's getting raised to that exponent, is 2. So each time you add 1 in the x direction, you are going to multiply by 2. I believe last time I called it the add multiply pattern. It just kind of helps you remember to like, okay, this is what I could do to find the next values. So let's go ahead and just do the math. 5 times 2 is 10. 10 times 2 is 20. Now working backwards, the opposite of multiplying by 2 is dividing by 2. So to figure out my next value going the opposite direction, 5 divided by 2 is just 5 over 2. 5 divided by 2 divided by 2 is just 5/4. So you can see here that I have a really quick value of tables. Now all I have to do is graph them. Now 1 and 10 is somewhere right over here. 2 and 20 is somewhere way over here. Again, don't worry about it. As long as you know the general shape of your graph, you're going to be fine. This is where you can get most of your points anyways. So finishing off -1 and 5/2 is roughly -1, 2 point something. Yep. And then -2, and then it's going to be a little bit lower, 1 point something. You can see here that you're going to start getting that curvy exponential. Now make sure that when you guys are having your curve, remember your domain and range, that you're never going to cross 0. You can see here as you divide by 2 and keep going up and up, you're never going to get to 0 because you keep cutting it. It's going to keep getting smaller and smaller and smaller. So make sure you keep that in account when drawing your graph. So this is exactly pretty much what we covered on Wednesday. Just pretty much just filling out tables and kind of playing out with those patterns. Now this is graphing exponential functions. What we're going to start today is pretty much solving exponential equations. Now, just to be sure that we are on the same track, exponential equations are literally just equations that have variables as exponents. Now, there is one key concept, one key strategy that can be super beneficial for you when solving exponential equations. Now, this isn't always going to work. This is just one strategy that we are going to build on. It's kind of like having the tools in your toolbox type of thing. It's just one tool. If you could recognize this following concept, it's a little bit easier to solve these. And of course, it ain't always going to work correctly. And then Monday, we're going to figure out what do we do when that happens. So what is that key concept there? So if you ever have an exponential equation, and let's say that b is a positive number other than 1, and let's say you have some base getting raised to the x, and it's equal to the same base. So notice that both of those are b's raised to some y. Well, then we can note that x is equal to y, because this makes perfect sense. If I have some base raised to some number and it's equal to the same base raised to another number, well, if these are really equal, that means that the exponents have to be equal. So really, if you ever arrive to a situation like that, I like to think of this as scratching out my bases and just setting my exponents equal to each other, and then you can deal with what you have. So that is a very, very simple concept, but of course it's not going to be as simple at times. But before we start getting to those problems, let's go ahead and do problems like 1 to 3 that are a little more straightforward here. Now, notice that the first thing I want you to do is to solve for x of the first one. Now, it is your job to recognize that this is an exponential equation. How do we know? Because we have a base with a variable in the exponent. So it's your job to find the value of x, that when you take that 5, raise it to x, it's equal to 5 raised to 3. Now you can see here that it's very clear that I have two bases that are equal to each other. Well, if two bases are equal to each other, that means the exponents have to be equal to each other. So we know that x equals 3. Now, that is a very, very simplistic kind of basic way just to get you guys in the flow of what to look for and why we want to look for it, because you can see that it's actually quite easy. And this makes sense because if you were to plug in this value, of course, 5 raised to 3 equals 5 raised to 3. Now let's go into the second one. This one's a little bit more tedious, but it's showing the same concept. Notice I highlighted my two bases. The reason why I highlighted them is because they're exactly the same. Now, if you have two bases are equal to each other, that means their exponents have to be equal to each other. So that means that 2x has to be equal to x plus 8. Now you can see here that it wasn't as simple as number one, but it's pretty straightforward. We can solve this quite easy. So in order to solve this equation, notice that you don't even have to worry about your bases. You just really concentrate on getting those exponents equal or whatever's left from them. So let's minus x on both sides. You end up with x is equal to 8. So you can see there that it's actually quite straightforward. Now, are problems always going to work this way? No. If you look at number 3, notice that we have a base of 5 raised to an x with a base of 4 raised to the 5. Can I set this x equal to 5, the exponents, aka equal to each other? And the answer is no, right? Because notice that your bases are not equal. So again, when you don't have like bases as easily as you did number 2, that's the strategies that we're going to develop later. Especially on Monday and Wednesday, logarithms can get very complicated in terms of solving, so it's kind of nice to practice them as much as possible. But in terms of today, if you understand this basic concept, I'm going to show you how pretty much we're going to work on together on how this simple concept can look kind of tricky at times. But if you have that in the back of your head of okay, that's my strategy, that's what I want my end goal, because I'm able to solve them, you're going to be okay. All right, guys, so if you notice in this problem here, notice I have a base of 3 that's getting raised to a very specific exponent, which is 2 to the n plus 1. And that specific exponent has a variable. So I know that this is an exponential equation. So when you see random problems, they're not going to tell you, hey, this is this, this, and that. You need to be able to recognize it. So when I see this, I see a variable in the exponent. So I automatically train my mind to start thinking of the strategies that I know in order to solve exponential equations. So of course, this is our first one. So all these problems are going to be tailored to this strategy. But as we move on, always keep that mindset that you have multiple tools to solve the same thing. Choose the one that is easier for you or more convenient to the exact problem. So nonetheless, let's figure this out, because we know if we have two like bases, we can just set the exponents equal to each other and solve for what that variable we need to be that is in the exponent. But notice here that we have a 3 and an 81. Unfortunately for us, those are not like bases. So we cannot just set the exponents equal to each other. But this is where you have to take or bring past knowledge on how to solve these problems. Now remember your rules of exponents and how to write exponents. 3 is a base. Is there any way that I can rewrite 81 as a base of 3? AKA, does 3 raised to any number equal 81? Now, of course, there's probably some of you that probably know that on top of your head, but I am not one either. So what I like to do is always kind of have my calculator in hand to kind of figure out what those exponents are, or if I could rewrite 81 as a base of 3. So you see my calculator is loading up. Give it some time, please, and we'll show you how. All right, so you can notice here, I'm trying to rewrite 81 as a base of 3. So I'm thinking in the back of my head, does 3 raised to something equal 81? So of course I know that 3 squared doesn't equal 81, but let me show you how the process looks. You can see here that I put 3 squared, which equals 9. So I'm going to go ahead and just do 3 to the 3rd power now and keep going and to see if I could get that 81. Now notice that there is no cubed here, at least not that I see. But whenever you want an exponent, all you have to do is click this little button. It looks like the top of the house. I don't know why, but a lot of during my math class, call it a caret. So I'm going to press that caret button, and you can see here that it gives me that little exponent. I'm going to go ahead and plug a 3. I'm at 21, so unfortunately, I'm going to keep going until I see if I hit an 81. So let's try 3 to the 4. And you can see here that, yes, we can rewrite 81 as a base of 3 because 3 raised to the 4 is 81. So let's show you how that works like at least on paper. So what did I do again? Notice I highlighted those red because those are my bases. When I looked at those bases, they're not exactly the same. So I'm going to try to rewrite one as the other. So I'm looking at 81, and I just figured out that 3 raised to the 4th is 81. Now, these two things are exactly the same. You haven't done anything mathematically different. So all I did was rewrite it. There's not really much else to do. I just put that as a 3. Let me go ahead and put that as a 2. And now you can see that this becomes a level 1 problem, just like the ones that we did above. I have 2 bases that are exactly the same. So that means if I have a base equal to a base, that means that their exponents have to be equal. So 2n plus 1 has to be equal to 4. Now you can see that I could solve for that variable that was once in the exponent spot. So let's just go ahead and solve it like normal. That's -1 on both sides. 2n is equal to a positive 3. And of course, dividing by 2 at the very end, you end up with n is equal to 3 over 2. And you can see here that if you were to check this value out, remember at the end of the day, what we're doing is trying to find a value that makes this equation true. So if I had 3 raised to the 2 times my n, which I just found to be 3 over 2, plus 1 is equal to 81. If I were to solve this, I would start with all my work inside of the exponent. Now 2 times 3 halves is just 3. You notice that you end up with 3 plus 1, which equals 4. We just found out in our calculator that 3 raised to the 4 is 81. So you notice that this checks out perfectly. And we're pretty much ready to move on. I'm not going to really ask you guys to check your guys' answers, but this is the mindset that I want you guys to be in today, because all the problems are going to be tailored to this strategy because I want you to practice it. So let's start with number 1. If you're feeling confident, move to number 2. You'll notice that number 3 and 4, you know how to do it, but I haven't showed you how. So I definitely want you guys to probably challenge yourself and see if you can figure out number 3 on your own. And you can see that these all kind of grow in difficulty. So try number 1. We'll go over them in a couple seconds or a couple minutes. And then we'll see, make sure that you're going down the right path. All right, guys, so let's go over numbers 1 and 2 to make sure that you're going down the right path. So as I see this problem again, it's just like the ones before, where the first step is to recognize what kind of equation that you have. And if I look at number 1, I can clearly see here that I have an exponential equation. Now, if I am lucky, I could rewrite the bases to be equal to each other, and then I can worry about setting the exponents equal to each other, and then actually solving for whatever I need to at that point. So if I look at this problem here, I have a base of 4 and have a base of 64. Now, unfortunately for us, this isn't the same. They're not equal, so they're not like bases. But I believe we could rewrite 64 as a base of 4. And I think that's true because if I type in my calculator, or if I really just multiply 4 times 4 is 16, times 4 again equals 24. So I know this is just 4 raised to the 3rd. And now you can see that this one was pretty straightforward. I have my 2 bases that are the same. That means that the exponents have to be equal to each other. So 2n minus 1 has to be equal to 3. Now, you can see that we can solve for the variable now. So let's go ahead and add 1. We end up with 2n is equal to a positive 4. Dividing by 2 on both sides, you end up with n equals a positive 2. If you were to plug this back in, you see that it is true that it checks out. So again, very, very kind of basic strategy, but kind of what I like to call it incognito, because the strategy is there. You just have to do a little pre-work to make sure it fits to what we are trying to do, which is to get those bases the same. Now I have a base of 3, a base of 81. I believe 3 raised to the, 3 times 3 is 9, times 3 is 27, times 3 would be 81. So I noticed that 3 raised to the 4 is 81. And then you have 3 raised to the 2n plus 1, just rewriting the other side. And then again, you have your base equal to a base. Luckily for us, again, we know how to, or it's really convenient for us because all we have to do is worry about the exponents. 2n plus 1 has to be equal to 4. Solving for this one, I end up with 2n is equal to 3. Dividing by 2, n is equal to 3 halves. I'm not sure if this was exactly like the one we did above, but worked out very, very similar, even if it was or wasn't. You get a second. Let's double check. I'm curious now. Oh, it is the exact same one. So there you go. You got it twice. I'm not sure if you noticed it. Sometimes that happens. All right, so let's go ahead and do number 3. Notice that number 3 is a little bit weird because according to the strategy, we have a base equal to a base. We can just worry about the exponents, but unfortunately for us, we don't have the same base. Can you rewrite 8 as a base of 4? Well, no, right? Because 4 raised to the 2 power is 16. There's no way to do that. And of course, you can't rewrite 4 as a base of 8. So you're kind of like, oh my goodness, what am I going to do with my life? And the answer is try to think of a base that you can rewrite both of these. You have to start thinking of different bases, and you'll notice that what I always like to do is just start off with 2. Can you rewrite 4 as a base of 2? And the answer is yes, because 2 squared is 4. So notice what I'm going to do here. I'm just going to rewrite that 4 as 2 squared. I'm going to leave everything else the same. So notice that this 2x gets rewritten out the same. And then now I have that 8. Does 2 raised to anything? Can I rewrite 8 as 2 raised to anything? And the answer is yes, because it's 3. And you can see here that all I did there was, again, rewrite on my exponent, just to make sure that you can see what happened there. I'm going to change colors. All I did here was I took my bases and I asked myself, is there any number that I could rewrite both these in the same base? And the answer, yes, is 2. And I just rewrote those and rewrote everything else the same. Now notice that this, I can't just set the exponents equal to each other just yet, because notice it's 2 raised to the 2nd power and 2 raised to the 3. This is where you have to remember your rules of exponent. You have something raised to an exponent, raised to an exponent. How do I simplify the exponents? Do I add? Do I subtract them? Do I divide? Do I multiply? And the answer is that you multiply. Your base stays exactly the same. Make sure to multiply your exponents. 2 times 2x is 4x. If you look at the other side, if you're going to simplify these ones, because you have the base raised to an exponent, you're going to multiply 3 times x minus 1. Now make sure that you think of multiplying everything. So that's why I put in parentheses to visually see it. This is going to be 2 raised to the 3x minus 3. And now you can see here that you have your bases equal to each other. All you have to do is set the exponents equal to each other to be able to solve for that. And let's just go ahead and solve for it. Minusing 3x to both sides, you end up with a single x is equal to a -3, which is awesome because that is my answer. If you were to plug those back in, it would work out perfectly. So yeah, that's how you all right, so for number 4, you can see here that we have an exponential equation. So we need to find what strategy will work out for us. Now notice that we have a base of 32 and 8. Now unfortunately, we cannot rewrite 32 as a base of 8. But what we can do is rewrite it as a whole entirely different base. Because I believe 2 raised to the, let's see, 2, 4, 8, 16, 32. 2 raised to the 5th is 32. Now keep in mind that I'm just going to rewrite my exponent because all I did was rewrite 32 as a base of 2 raised to the 5th. And then notice I can do 2 raised to the 3 to get that 8. And then you have your x plus 1 just kind of hanging out there. Now you can see that they look like they're the same bases, but unfortunately you have to simplify your exponents first. Notice we have 5 times x, which is just 10x. So we can write 2 raised to the 10x, which is equal to 2 raised to the 3x plus 3, because again, all I did was multiply there. Bases are the same. Notice that you end up with 10x is equal to 3x plus 3. Solve for your equation. Let's minus 3x on both sides. You end up with 7x is equal to a positive 3. Dividing by 7, x is equal to 3/7. And that's pretty much it. Now, just to make sure that you guys see multiple examples to ensure that there are no surprises, or at least you have a decent idea, let's go ahead and cover number 5 because it's just really bringing back the rules of exponents. I can see here that I have 1/3 raised to the x is equal to 3. Now, notice that my bases are exactly the same, but unfortunately, my base in this situation is in the denominator. So what can I do with my life? Well, remember that it's actually quite easy to move a value from a numerator and a denominator. All you literally have to do is make the exponent negative. So what I'm going to do is move that base up to the top. Notice that there's already a 1, but 1 times anything is itself. So I know I could raise my 3 to the numerator. Remember that whenever you have a negative exponent, it moves it to the opposite side of your fraction. So um, my bottom disappears. Notice that I just have a 3 raised to the 1. Let me make sure to not forget my exponent of x there. To the x is equal to 3 raised to the 12. Now you can see that both my bases are in the numerator. I still have to simplify my exponents, which makes it just a negative x, because negative 1 times x is a negative x. 3 raised to the 12. Two bases are the same. All you have to do is add the exponents. Now I like to write my 1 in there so I can visually see that all I have to do is divide by 1. And then you end up with x is equal to a negative 12. So again, this was a very quick example just to highlight, to not forget that if you have a fraction and you want to pretty much get rid of the fraction, the denominator, an easy strategy to do it is just to make the exponent a negative, or change the signs to it, really, because that is what moves it to the opposite side. And then after that, you'll be golden, because you'll notice that it's kind of straightforward. So yeah, that's pretty much just it for today. If you have any questions, please let me know.